Welcome to part 8 of Senior Developer in 24 Hours. My name is Andres, and today we're going to be talking about how to keep your team productive. Okay, so what is the takeaway? What are we trying to get out of this video? And it's actually two videos. This is the first part of how to keep our team productive. But after watching these two videos, you should have a good understanding of the importance of being able to identify external dependencies upfront. And of course, being able to manage those dependencies. Because we're going to need strategies to work around misalignments on the dependencies that we have for our application, for our service, for our component. And we're going to understand how these dependencies play into the software development lifecycle. How are these dependencies going to affect how fast we go, where we get stuck, and how we can work around those things? Because part of the role of being a senior developer is making sure that we can keep our team on track and being productive. And the truth is that today's software is really complicated. We have many dependencies. We require complex infrastructure, whether it's infrastructure in the cloud or infrastructure on-prem. When we're talking about backend applications, we're talking about databases, we're talking about API gateways, we're talking about web servers, we're talking about external APIs, we're talking about messaging, we're talking about a lot of different components that we're going to depend on to have our component operate. Microservices have gone a long way to try to limit those dependencies, but nonetheless, we have to interact with the world that's out there. We also require the right access. If we're working in a large company, in a large organization, getting the right access is going to be quite a task, and it's something that we have to make sure that it is there for us to actually get our work done. And to achieve a lot of those things, we have to coordinate with other teams. There is a lot of work, a lot of effort trying to get self-service up and running so that teams can provision their own infrastructure, that they can provision their own databases, that they can provision their own projects on the cloud, things like that. But at the end of the day, we still have to coordinate with other teams. We might also have to coordinate with other teams that are still building components that we're going to depend on. So all of those things have to be taken into account as we are trying to make our application work. So, the waterfall. A lot of people have heard about this term, and it is not really a development methodology, although it has been described as one. But it is actually the way things actually work in the real world. Because things have to happen in a sequence. We try to plan for it. Sometimes it works, sometimes it doesn't work. But when you have multiple work streams working side by side, there is going to be that need to keep those two things aligned. And in theory, if everything were great, waterfall methodology, or even if it's not taken as a positive term, tells us that we should be able to design our application, we should be able to code our application, test it, deploy it, and maintain it. But what is the problem? Throughout each of those steps, we're going to run into cases where we have to interact with other teams to get things done. And the truth is, this rarely works as expected. Why? We have mismatched timelines. We are working as fast as we can. Our partner teams are also working as fast as they can, but it is really rare in which both teams are completely aligned. And when you have more than two teams, when you have an infrastructure team, you have a security team, things like that, things get even more complicated. We also sometimes have mismatch requirements that we have to figure out um, how to arrive at some kind of compromise. Sometimes there are gaps. Sometimes we depend on something, and it turns out that no team is working on this. The other team thought we were working on it. We thought the other team was working on it, and at the end result is it doesn't get done. So, sometimes things fall through the crack. We have to be ready to be able to account for those things and work around them. Because all of these things are going to create delays. And delays are going to affect the timelines. Um, and it is incredibly hard to try to account for things that are not expected. Delays are never expected, otherwise they would have been taken into account. And there's also bugs that we have to deal with that will require some level of rework because, things didn't work as expected. Um, and as we all know, software development is an iterative discipline. We build one iteration, we test it, we try it again, we squash a few bugs, we try it again, we improve the functionality, we add more functionality, and so on. So we keep moving forward. Which brings us to Agile, which is supposed to come to our rescue, but maybe it doesn't really solve all of our problems. Nonetheless, we still use Agile because when we compare it with a waterfall approach, ironically, it makes it more likely for us to finish on time if we have an Agile um, methodology rather than a very strict waterfall where we have a very strict sequence of events. And um, flexibility is what makes Agile work. It also has some other benefits. It improves communication because we are forced to constantly reach across teams. We're constantly forced to reach and talk to people that are within our team. So, it improves that communication. It also reduces the risk of defects because we are iterating quicker, we're getting feedback quicker, we have more opportunities to integrate our code. So it reduces a little bit the opportunity of bugs and defects to make it all the way to production, where things are a lot more expensive to fix. It increases the morale of the team, having close collaboration, having open channels of communication. They help our team members be more motivated. And finally, the most important thing, it helps us to adapt to change. Because again, timeline shift, we have to be ready to adapt to those timelines. And waterfall does not lend itself to adapting to this change. So what does this mean in the real world? Because schedules will always slip. Priorities change. Or maybe priorities were not properly aligned in the first place. Things have to be redone because we run into bugs, things like that. So we have all of these problems. So, in such a world, how do we stay productive? Okay. One of the most important things is that regardless of what methodology we have, we need to have clear goals and expectations. Again, they should be clear, they should be realistic, they should be attainable. Otherwise, people start ignoring the expectations, the goals, and so on. We should be able to adapt to changing conditions. Because it doesn't matter how good our plan is, it doesn't matter how good our Gantt charts are, there is always going to be things that we will have to adapt to, as the project goes on. We also need to have regular feedback from the code itself, for example. from stakeholders and SMEs, the people that have the domain knowledge of the code that we're writing, from peer teams as we are coordinating to get things done, to um, get infrastructure stood up, get access to the APIs that they're building, be able to consume components that they have built that we can reuse, things like that. So, we want to be in regular communication with those other teams. And we also want to be in regular communication within our team. And well, how do we achieve this? Um, from the code itself, automated tests are the best way in which we can get that feedback quick enough. For stakeholders and SMEs, we do regular demos to show them the progress that we've made, and for them to call out if something is missing, if something is not really what they expected, if there's any kind of functionality that we have to add or adjust, things like that. With peer teams, regular sync meetings to make sure that people are aware of where we are, what we are expecting from other teams, and also what other teams are expecting from us to make sure that we are making progress. And finally, within the team, with regular stand-ups to make sure that people are making progress, make sure that people are not stuck, make sure that people are not trying to complete something that is in the schedule, even though they run into the problem that whatever prerequisites for that task actually didn't get done in time. And, the idea is that we want to shift things left. The sooner we identify an issue, the simpler it is to fix. And when I mean an issue, I just don't mean a bug. Of course, if we can identify bugs earlier, it is cheaper, faster, and easier to fix. But this also applies to other kinds of issues, especially issues that arise when we're working again in a large organization where we have a lot of dependencies, and some of those dependencies might not be done in time, might not be exactly what we need, where we have to go through all of those motions to get the things that our team requires. Again, to keep up with the notion of agility, we also want to make sure that our team is empowered, that they have the level of autonomy that allows them to experiment in a safe place. We want to make sure that they have access to effective tools. And these tools, again, this ties back to what we were talking about, regular feedback. We want these tools to be able to quickly get them that feedback. We also want them to have the tools that will allow them to effectively integrate with other parts of the system. And at the end of the day, keep in mind that code is nothing but a tool. So with that said, not all code will endure indefinitely. Sometimes, we have to write short-term code to be able to solve a short-term problem. And discarding code is okay. I am a developer. I take pride in the code that I write. So writing code that I know is going to be disposable in a matter of weeks, in a matter of months, it does go a little bit against my craft. But we have to understand that at the end of the day, we are writing code just as a tool to be able to achieve an outcome, to be able to create a component, an application, a service that does a certain task, and we are using this code to make this work. So, we are developers again. We write code to do things. And just like we write code to do these things, we can write code to get around roadblocks. So we need to identify the external dependencies. A lot of this should come from the design. The design should make it easier for us to identify the external dependencies that could put our development at risk. So what are we talking about? We're talking about the infrastructure that we don't control. If it is something that we can set up on our own, then it becomes a lot more certain whether This is going to fit within our timeline, whether we can scramble to get the infrastructure set up and running, things like that. But if we do not control this infrastructure, then we should definitely identify it as a possible risk that could affect our development. Same thing with APIs that are not ready. For example, if we depend on APIs or services that are going to be provided by another team, it could be, for example, some kind of data processing, some kind of uh, external API that we have to reach out to, things like that. If those APIs are not ready, if they're not available, um, things like data pipelines, all of those things, if they're not ready right now, again, they are something that we should flag as a possible risk. Same thing with common components that will consume, mostly libraries, things like that, that are actually embedded into our code. If they are not under our control, if they're getting built by other teams and they are not ready, then again, this is a risk that we should identify as we're going through the process of actually trying to implement our code. Okay, so let's talk a little bit more about infrastructure. In particular, we have to identify what do we need, when are we going to need it, how are we going to access it. And a lot of this depends on where this falls within our plan. So for example, what do we need? And this is fairly straightforward. Things like databases, servers, Kubernetes clusters, because now, we are always trying to deploy things in containers, but we still need to have the infrastructure where that container is going to run. Firewall rules, CI/CD pipelines. If we do not control the CI/CD pipelines ourselves, if these are things that are set at an organization-wide level, this is definitely a risk if those pipelines are not ready, if those pipelines are not at a point where they can fully support the use case that we need. And a lot of other things that are considered infrastructure, and again, are outside of our direct control, outside of the control of our team. When do we need it? And this is another critical point because normally, development happen in phases. The first thing is, hey, are we going to need any of this infrastructure to develop, to be able to run our IDE against, things like databases or CI/CD pipelines obviously are needed at development time, things like that. Do we need this to have a development environment for us to be able to write the code? Do we need it to be able to run automated testing? Sometimes we might get away with running some of this infrastructure locally on our laptop, but we might not have that flexibility when we're running the CI/CD pipelines. Do we need it for integration? Do we need to have an environment where our component is going to interact with other components, with other services, with other APIs? Do we need it for production? Obviously, we're going to need some kind of infrastructure for production. Is that already set up, or is this something that we're going to depend on? If we're talking about custom APIs or custom libraries that are getting developed by partner teams, again, we need to ask ourselves some of the same questions. When will it be ready? Will it fulfill the needs that we have? Can we get early access to see how things are going, to try to start integrating things, to see how far along they are in being able to meet our requirements? Can we have some input into the design? That is another good question that we should ask to make sure that, again, we avoid as much as possible misaligned expectations. Okay, what are some of the obstacles that we're going to run into? For example, we're going to run into mismatched timelines. They might have their own priorities. We have our own priorities. We might expect some piece of functionality, some piece of infrastructure, a new API to be ready at some point in particular. It might not get done in that time because they have, again, different priorities, different workload, things like that. There will also be mismatched expectations. We might expect that the new API that they're doing is going to provide A, B, and C functionality, but at the end of the day, it doesn't really provide what we require. We expected something different, there was some miscommunication, and now we're in a place where we don't have, again, the functionality that we need to keep moving forward. Sometimes aspects just get overlooked. Things fall through the crack all the time, and we have to work around those things. Delays. Delays are unavoidable. We can try to minimize them, but it is foolish to try to assume that there is going to be no delays. And keep in mind that it is our job as a senior developer to help our team overcome these obstacles. And when we're working with a very complicated project where we have a lot of dependencies, where we have a lot of uncertainty, having a plan will greatly increase the morale of the team. You don't want to go into a project where your team already feels that they're being set up for failure. So it is our job as senior developers to give them that confidence, to give them that plan, that set of action items, and hey, this is how we're going to achieve our goal. This is how we're going to overcome the obstacles that we have that we have identified so far, and we're going to follow basically the same approach as new obstacles show up in our way. Okay, now let's quickly go back to the takeaways that we laid out in the beginning. We wanted to understand the importance of identifying external dependencies. Again, external dependencies tend to be the most critical points that will hold us back from being to achieve our goals. Agile will help us, manage the internal workload, manage the internal tasks that we're dealing with, but external dependencies, they tend to be more complicated because they are somewhat outside of our control. Again, we want to learn strategies to be able to work around dependency misalignments. We're going to go into detail in the next video about specific strategies. And we also want to, we wanted to put the dependencies in the context of the software development lifecycle. And we're going to go into more detail about how the strategies that we're going to talk about fit within this development lifecycle. So just a quick summary from what we've seen today. The time of your team is extremely valuable. Coordination with other teams is complex and timelines slip. This is unavoidable. We have to deal with it. That is part of our mission. That is part of our role as a senior software developer. Good design is critical because good design is going to give us the opportunity to identify the dependencies, and it's going to give us the opportunity to mock the missing dependencies, to figure out how to work around all of those things. So if you enjoyed this video, please follow me on our journey. In the next video, we're going to talk about the specific steps and techniques to keep your team productive, depending on the type of roadblock that we're running into. And with that said, thank you for watching. Don't forget to subscribe. You can also follow me on social media. I am in Twitter at aolarte, or you can follow me at Mastodon at aolarte at cloudnative.social, or check out my website, www.javaprocess.com. Thank you, and I'll see you next week as we continue on this journey.